Hi, today we will continue our journey. So let's see where we stopped last time. We cleaned all the data last time, and this is our file here. We are making read CSV and head, and there was no nulls, no duplicates. So let's see, we need to check what is our features relation with our prediction. We have the buy price and sell price. We need to know which algorithm exactly we will use, linear or not linear. So when we are checking the buy price and sell price, we see here with a scatter, we can see almost linear relationship between both. So this is mostly will be our idea which algorithm we will use. So let's check. We have the Emirates and unique. We will get the names all in Emirates. We will get the unique names in Emirates. We have 7 Emirates. We will number them by 7, 6, 5, 4, 3, 2, 1. And this is according to the prices. When you are studying the data, you will find this is almost the most important, starting from here, then going down. So I am trying to tell the program to give more importance to Dubai than Fujairah. So I will use replace, okay, to replace the names of Emirates, and also I will use the type Studio 1 PHK 2 PHK with values 1, 2, 3. Okay, so after using this, we will print the head. Now the Emirates is numbers and type is numbers. So let's drop the not important data, which is dates, for example, and region. I will not use region because we have many regions as we discussed last time, and we don't have sufficient data for it. So I will use only the Emirates as my indication for the price. So currently I will drop sell, buy, sell dates, buy price, region. I will use axis 1. Then I will take Y as a variable. I will take the sell price, so I'm separating the predicted values, which is the sell price, with the remaining data, which is it will be the Emirates, buy price, rental, has pool, area, square feet, has amenities. So let's print them. This is now my X, my data, which will I will use for predicting, and Y is my predicting price. To study more the data, you will see here, this is the data we studied last time, all of this data. So let's go directly and we will use get dummies to fill all of this data. And we will start from here, machine learning. We need to make a scaling for all of this data. Okay, so all of them will be between 0 and 1. And we will use min-max scaler for this. We will make SCX and SCY, and we will put them and fit them like this. X equal SCX fit transform and SCY fit transform, and we will make the values 1, -1 and 1, okay, to make 2 dimensions array. Like this, we are putting the X and Y in min-max scaler. Let's check how it's look like. This is now the current data, and this is Y. After that, we need to split our data, and this is depending on the industry. Some use case telling 30 for testing and 70 for train, or 60-40. It depends how you will use. We will use here only 20% for testing and 80% for training. And we will use here from sklearn model selection import train split, train test split, and we will use xtrain xtest, ytrain ytest, and this is the equation which telling me I will use it, and I will use 0.2 only. 0.2 of the data is the test size. Random state, there is a lot of people making 42, there is a lot of people making 1 and 2. This is a random value, so it's not important that much. So this is now the X train, and this is now the Y train. So let's start with sklearn, which we will use, as we mentioned above, we will use the linear regression, and we will tell model equal linear regression function. Then we will make model.fit xtrain and ytrain. Model.score, which will give me score for the train, for the xtrain and ytrain. And I make round to just simplify the result. He give me 75. So this is the score of the train data. And I will make the same for X test and Y test. And here he give me 85. So he give me a score on the train, 75, and give me 85 on the test, which the data he didn't see before, which is great result as a start. We have a lot of algorithm also we will use, but this is a good start. And we will also explain if we have overfitting or we have another underfitting models, how we will check them. But currently, this is the normal model algorithm. Let's check the remaining algorithms, how it would look, how we can see the other algorithms, how they are dealing with this data. We will use here the SVR. We will tell it from sklearn.cvm import SVR, and we will tell model SVR model.fit xtrain and ytrain, and we will give it score. This is score for training. This is score for testing. He give me 69 on training and 65 on testing, which almost we can make hyper tuning. So it's mostly, we can say it's acceptable, but it's not good as linear regression, of course. So let's check another thing, which is random forest. We will use here sklearn in simple import random forest regressor and model equal random forest regressor, and we will run this as normal, and we will give it score. So 95 on train and 76 on testing. Here we can see that this model is overfitting. So this random forest is not our best use in our case here in our model. If you like this content, please like and share. So let's check XGBoost. This is here, and we will check here the model and testing. We have 99 on train. Also, we have 58 on testing. This is totally not acceptable. This is totally clear overfitting. We will discuss the overfitting and underfitting. All of this we will discuss in a theoretical part. But currently, I'm telling you how we can see this practically in a model. Here, this is decision tree. Let's check 99.9. This is the train, and 55 on the scoring of the test. So currently, as you see here, all of these models, as you see, some of them is acceptable, which was the linear algorithms, and some of them need hyper tuning. We will use another things, and also some of them is totally not acceptable. How we can simplify things and make one function to test all of them and give me the best results without making all of this. This is we will see in next time. See you.